Now next we have to learn about curl and divergence. So our next heading will be divergence and curl. Now these two are calculated for a vector function, divergence of and curl of a vector point function. Now what is the meaning of this vector point function? The meaning of this vector point function is that this vector f will be in this form: f1i plus f2j plus f3k, where this f1, f2 and f3, these are some function of x, y, z. Okay, example of vectors are vector point function will be velocity, acceleration and those type of things. So now divergence and curl, these two are calculated for any vector point function. Here f1, f2, f3, these are function of x, y, z or some constant in some cases. So first we have to calculate the formula for divergence. Now before that we should recall our del operator. This del operator was I del by del x plus j del by del y plus k del by del z. This was our del operator. So now first thing, divergence of f, okay, this is vector f. So divergence of vector f, vector point function f, this is given by the formula divergence of f. This will be nothing but del dot f. Okay, dot product of these two vectors, one this del operator and other this vector point function, is called divergence. And it is very easy to remember because in case of divergence you have to take dot product. Okay, divergence means you have to take the dot product of these two vectors. Since dot product is a scalar quantity, divergence will be a scalar quantity. Now if you take the dot product of these two vectors, then you can easily see that you will get partial derivative of f1 with respect to x, partial derivative of f1 with respect to x, partial derivative of f2 with respect to y, plus partial derivative of f3 with respect to z. We will see the meaning of divergence and curl in detail, but first you should know how to calculate these things. So this will be the formula for divergence of a vector point function. Okay, del f1 by del x plus del f2 by del y plus del f3 by del z. Now next we have to see the formula for curl. So if we have to calculate curl of this vector point function f, then curl of f, this is given by the formula del cross f. Okay, and it is very easy to remember. Divergence was dot product, curl is cross product. Okay, in case of divergence, divergence dot product, curl cross product. So if you take the cross product of these two vectors, del cross f, then you will get first row will be I, j, k. Then for del operator, the x, y, z components are del by del x, del by del y and del by del z. And then the component of vector f are f1, f2, f3. So this will be the formula to calculate curl of any vector point function. Okay, so divergence will be this dot product, curl will be cross product. Now with the help of one problem, we'll see how to calculate these things. So suppose if the question is find divergence and curl of this vector f, which is say x square plus yz. Suppose it is x square plus yz I plus y square plus xz j plus, let me write the third component here, so plus z square plus xyk at point 1, 2, 3. Okay, this point is given, and at this particular point we need to calculate the divergence and curl of this vector point function f. So if we need to calculate the divergence, then divergence of f, this will be vector del dot f. Okay, this del operator dot product with f. So the formula was del f1 by del x plus del f2 by del y plus del f3 by del z. So this will give us, this is your f1. So f1, this is f1, this will be f2, and here this will be your f3. So you need to differentiate f1 with respect to x. So you can easily see that derivative of f1 with respect to x will be 2x. Derivative of x square is 2x. This will give us 0. Derivative of f2 with respect to y, 2y. With respect to z, 2z. Okay, now if you take 2 common from here, then you will get x plus y plus z. So this will be the expression for divergence of f. Now the question was, we need to calculate divergence at the given point. So divergence of f at the given point 1, 2, 3, this will be, in place of x we have to write 1, y is 2 and z is 3. So this will give us 12. So for the given function at the given point, divergence will be plus 12. Now next part of the problem was, first one was calculate the divergence. The second part is find the curl of this function. So curl of f, this was the formula for curl was del cross f. Divergence was del dot f, curl was del cross f. So this will be I, j, k. The first row will be del by del x, del by del y, del by del z. Sorry, this will be the second row, and the third row will be f1 is x square plus yz, f2 is y square plus zx, and f3 is z square plus xy. So this is f1, f2 and f3. Now if we expand this determinant along the first row, then I will get I. We have to multiply these, not multiply, we have to apply this operator on this function z square plus xy and differentiate y square plus zx with respect to z. So if I differentiate this with respect to y, then I will get x, minus if I differentiate this with respect to z, then I will get x, minus j into, now again erase this second column, differentiate this z square plus xy with respect to x, so I will get y, minus derivative of this with respect to z, so this will give us y. And similarly for the z component, you will get derivative of these two, so this will give us z minus z. So x minus x 0, y minus y 0, z minus z 0, so finally you will get 0 here. So for the given function, curl is 0. Now curl is 0 everywhere, so at the given point also curl will be 0. Now in this particular problem we have obtained curl as 0, but in some other problem you will obtain some expression, some vector for curl, and if the curl is asked at a given point, then in place of x by z you have to substitute those values. So this was fairly simple question, a basic question on how to calculate divergence and curl. For the divergence you have to take dot product of these two, and this will be the expression for divergence, this you need to know. And then curl is given by the formula del cross f. Now after this there are some basic points related with curl and divergence. Okay, total we are going to discuss 4 points about the meaning of this curl, what is when this curl will be 0, when divergence will be 0, what is the significance of these things when curl is 0 and divergence is 0. So now we are going to discuss about those important points. So the first point that you need to know is, if the first point will be, if divergence of velocity vector is 0, this implies flow is incompressible. Okay, if the divergence of velocity is 0, then the flow is called incompressible flow. Incompressible simply means that density is constant. Okay, incompressible flow means density is constant. So if divergence is 0, then it means flow is incompressible, and it is very easy to calculate, it is very easy to solve this result. See, velocity vector is, suppose ui plus vj plus wk. u, v, w, these are function of x, y, z. Okay, so this is velocity vector. So what will be the divergence of this velocity vector? Divergence will be partial derivative of x component with respect to x, partial derivative of y component with respect to y, partial derivative of z component with respect to z. So this will be divergence of V. Now we all know that continuity equation is, okay, in fluid mechanics you must have learned this continuity equation. So continuity equation is partial derivative of rho u with respect to x, rho is density, plus partial derivative of rho v with respect to y, plus partial derivative of rho w with respect to z, plus partial derivative of rho with respect to time is 0. This is continuity equation. So here if you see this relation, if density is constant, then what will happen? If rho is constant, okay, if density is constant, then first of all this term will become 0. And from all these three terms you can take this rho outside. So if you take this rho outside, you will get del u by del x plus del v by del y plus del w by del z. This is the equation that you are going to get, okay. And since rho is constant, you can write this rho, you can take this rho on right hand side. So finally you will get this expression. Now what is this? This is nothing but divergence of velocity vector. Okay, so if the flow is incompressible, if the density is constant, then divergence will be 0. Or you can also say the converse of this. If divergence is 0, then it means density will be constant, and if density is constant, then flow will be incompressible. So this is first point related with divergence. The second result you need to remember is that if divergence of any vector, okay, if divergence of v is 0, v is any vector here, let me call this as some other vector f. V we have used for velocity. So suppose if divergence of f is 0, then this means f is solenoidal vector. So this is second point that you need to remember. If divergence of any vector is 0, then that vector is called solenoidal vector. If divergence of velocity vector is 0, then flow is incompressible. If divergence of f is 0, then f is called solenoidal vector. Now the third point is, if curl of v is 0, this implies flow is irrotational. Okay, we'll see the meaning of this irrotational flow. So curl is related with rotation. Now if curl is 0, then it means there is no rotation, and it means the flow is irrotational flow. Now let me explain what is the meaning of this irrotational flow. Suppose if you have a particle which is moving in a straight line, okay, so it is simply moving in a straight line in this manner. So in this case it is not rotating about an axis through its own center of mass, it is simply moving in a straight line. So this means this flow is irrotational flow. There is no rotation here, the particle is simply moving in a straight line. But suppose if we have a situation where the particle is moving in a straight line and at the same time it is also rotating about an axis through its own center of mass. Okay, it is moving in a straight line and it is also rotating about an axis through its own center of mass. It is rotating about this axis. So this type of flow is called rotational flow. So while for the first case, when the flow is irrotational, in this case the curl of velocity vector will be 0. Since there is no rotation, particle is simply moving in a straight line. So here curl of velocity vector will be 0. But in the second case, when the particle is also rotating about an axis, the curl will be non-zero. So that is the meaning of this curl. If curl is 0, flow is irrotational. If it is non-zero, then the flow is rotational. And the last point is, which is very important result, if curl of f is 0, for any vector f is, if curl is 0, then you can write this f as gradient of phi. Okay, phi is some scalar function. So for any vector, if curl is 0, then you can write that function as gradient of phi, and this phi is called scalar potential. So this is very important point. If for any vector curl is 0, then it means you can write that vector as gradient of some function phi, and this phi is called scalar potential. So let me give you one example. In our first example we had seen that curl was 0, right? Our first example was this vector f was x square plus yz I plus y square plus zxj plus z square xyk. This was our first example, right? And in this example we had seen that this curl of vector f was 0. Now what is the meaning of this? This simply means you can write vector f as gradient of phi, and this phi will be called scalar potential. So now we are going to learn how to calculate this phi. So this f can be written as gradient of phi means I del phi by del x plus j del phi by del y plus k del phi by del z. So now this is your vector f, and the given vector f is this. Now if these two vectors are equal, okay, these two vectors are same vector, so in that case all the three components will be equal. So this means del phi by del x, this should be equal to the x component. So del phi by del x will be x square plus yz. Similarly del phi by del y, this will be y square plus zx, and del phi by del z, this will be z square plus xy. Now from here if you integrate with respect to x, then phi should be x cube by 3 plus xyz. From here you will get phi equals to integrate with respect to y, so y cube by 3 plus xyz. From here you will get phi equals to integrate with respect to z, so z cube by 3 plus xyz. Now if you combine these three, then you can write that phi will be x cube by 3 plus y cube by 3 plus z cube by 3, and you have 3 times xyz, so you have to write this only once, so plus xyz. Okay, only write distinct terms from here. So this will be the value of phi, this will be the scalar potential. And you can see that if you calculate gradient of phi, then you will get this function f. Okay, gradient of phi, so partial derivative of phi with respect to x, that will give you x square plus yz, these two will give you 0, so you will get this first term. Then partial derivative of phi with respect to y, this will be 0, you will get y square from here, this is again 0, xz from here, so this will give you second term. And similarly this third term will be del phi by del z. Okay, so if you want you can verify that if this is phi, then gradient of phi will be nothing but f. Okay, so this was very important point. If curl of any function is 0, then you can write that function as gradient of some other scalar function phi, and this phi is called scalar potential. So after this we will take some problems which were asked in previous year papers based on curl and divergence. Okay, so now we have these two problems on divergence and curl. The first question is, this was asked in GATE 2017 in mechanical. The problem is, for a given 2D flow, okay, for a two-dimensional flow, the velocity field is given by this formula. Okay, this is velocity vector. V is 5a1x plus b1yj. Sorry, here it should be I. This is x component. So this is x component and this is y component j. If the flow is incompressible, okay. Now what is the meaning of this word incompressible? Incompressible means density is constant. If density is constant, then what should be the divergence of velocity vector? This will be 0. So it is given that if the flow is incompressible, then which one of the following four relation is correct? So if flow is incompressible, then divergence of velocity vector will be 0. This means del u by del x plus del v by del y plus del w by del z. This will be 0. Now since it is a two-dimensional flow, there is no z component, only x and y component. So this is your u and this is v. Okay, this is capital B. This one will be a small u and this is small v. So derivative of u with respect to x, this will give us 0. a1 is constant, so this will give us a1 0 plus derivative of v with respect to y. So if you differentiate v with respect to y, you will get b2. So a1 plus b2, this will be 0. So correct answer will be option B. This was very simple problem. Once you know this, the meaning of this word incompressible. Incompressible means constant density, which means divergence of velocity has to be 0. So the correct answer will be option B. Now the next problem is, this is from GATE 2017. The problem is, if this vector f is irrotational. Okay, now what is the meaning of this word irrotational? If a vector is irrotational, this means the curl of that vector will be 0. Irrotational means there is no rotation. If there is no rotation, curl will be 0. So here the question is, what will be the value of this k1, k2 and k3? So if curl of f is 0, this means I, j, k, del by del x, then del by del y, and then del by del z. This will be the second row. The third row will be xyz component. So 3y minus k1z, then k2x minus 2z, and then minus k3y plus z, and this will be 0. So now if I expand this determinant, then differentiate this with respect to y, you will get minus k3. Differentiate this expression with respect to z. Okay, so we will get derivative will be minus 2. So I will get minus 2 minus j into, now for j we have to erase this second column. Differentiate this with respect to x, you will get 0. Differentiate this with respect to z, so you will get minus k1 plus k into I cap, j cap and k cap are the unit vector along x, y and z axis. So now if I differentiate for this k component, you have to differentiate this expression with respect to x. So that will give us k2 minus, then differentiate this relation with respect to y. So that will give us 3. This will be 0. Now if a vector is 0, then it means yes, all the three components are 0. So from here you will get the value of k3. K3 will be 2. From here you will get k1 equals to 0. And from there you will get k2 equals to 3. So k1, k2, k3, this will be 0, 3 and 2. K1 is 0, k2 is 3 and k3 is 2. So correct answer is option B. Okay, so these were two simple problems based on curl and divergence, and in GATE exam only these type of questions are asked from curl divergence. You have to know the meaning of this word incompressible. Incompressible means divergence 0. Irrotational means curl 0. And for any vector function f, incompressible means divergence of velocity vector will be 0. But for any other vector, if divergence is 0, okay, then in that case this f is called solenoidal. Okay, f is solenoidal vector. So these 3 points you have to remember. Now after this we'll talk about some important formula. Basically we'll see 4 different formula on how to calculate. See, till now we have talked about gradient, divergence and curl. Gradient was calculated for a scalar point function and gradient was vector quantity. Then we have talked about divergence and curl. Divergence and curl are calculated for vector quantity. Divergence was dot product of del operator with vector f, and curl was cross product of del operator with vector f. Divergence was a scalar quantity, curl was vector quantity. Now we are going to see some important formula. So the first one will be total we are going to see 4 different formula. So the first formula will be, suppose if we have to calculate say gradient of divergence of f. Okay, divergence of f will be a scalar quantity and we have to calculate gradient of divergence of f. So this will be the first form. Maybe I should write in this manner. See, our first formula will be, suppose if I have to calculate say gradient of f. Okay, gradient of f was vector quantity. So for this gradient of f we can calculate curl, and for this gradient of f we can calculate divergence, right? Curl and divergence, these two are calculated for vector quantity. Gradient of f is vector quantity. So first we'll see what will be the curl of gradient of f. Then we will talk about divergence of gradient of f. This will be our second formula. Then we will see curl of f. Okay, curl of f was vector quantity. So we will see the formula for divergence of curl of f. This will be our third formula, and the last one will be curl of f. And for curl of f, this will be vector quantity. So for this we can calculate curl. So these four formula we have to learn. See, gradient is vector quantity. For gradient we can calculate curl and divergence. Curl is vector quantity. So for curl again we can calculate divergence and curl. And divergence of f is a scalar quantity. So for that we cannot calculate curl and divergence. Okay. So now curl of gradient of f. Curl means del cross, and gradient of f is del operated on f. Okay, so del cross del f. Now this value is 0 for any function. If you first calculate the gradient of that function, and then you calculate the curl of that gradient of f, you will always get 0. So this is first result. The second one is divergence of gradient of f. So divergence of gradient of f will be, divergence is del operator del dot del f. Okay, this will give us gradient of f. This will be a vector quantity. Then you have to take dot product with divergence. Okay, and if you use the formula, then you will get this as del square f, where this del square is nothing but Laplacian operator. Okay, this del square is given a separate name. Okay, the del operator was, this del square is nothing but dot product of del dot del. Okay, let me explain this thing. This del operator was I del by del x plus j del by del y plus k del by del z. So this was del operator. Now this del square operator is defined as second derivative with respect to x plus second derivative with respect to y plus second derivative with respect to z. Meaning that suppose if I have to apply this del square on some function f, so this should be second derivative of f with respect to x plus second derivative of f with respect to y plus second derivative of f with respect to z. So this del square operator is called a Laplacian operator. So divergence of gradient of f, this will mean del dot del f. So this will be del square f. So this is second result. The third result is divergence of curl of f. So divergence of curl of f, this will be del dot, curl was del cross f. Okay, now even though del is an operator, here you can apply the concept of a scalar triple product. Okay, in our earlier discussion we had seen that this thing was called a scalar triple product of three vectors a, b, c. Okay, a dot b cross c. And we had also seen that if any two of these three are same, then the value of this scalar triple product is 0. Okay, if a and b are same vector, in that case a dot b cross c will be 0. So here you can see that this del operator, okay, and this del operator, these two are same. So del dot del cross f, this will be 0. So this means divergence of curl of any function is always 0. Okay, divergence of gradient of f, this will be del square f. Curl of gradient of f, this will be 0. Divergence of curl of f, this is again 0. And finally curl of f, so this will be del cross f. Okay, curl of f, so curl of f will be del cross f, and then again curl, so del cross f. Now here we need to apply the concept of vector triple product. A cross b cross c, this was a dot c into vector b minus a dot b into vector c, right? This was the formula for a dot b cross c. So curl of f, this will be del cross f. Now here we need to apply the formula of vector triple product. So this will be 1 dot 3, so del dot f, this will give us divergence of f. Now since this del is an operator, there is no point of writing this del after this function, so we'll write this del here, minus dot product of first two, so dot product of del dot del, this will give us del square f. So this will be the formula for curl of f. This will be gradient of divergence of f minus del square f. Okay, so these are some of the important formula that you need to remember. First one is curl of gradient of f 0, divergence of curl of f, this is also 0, divergence of gradient of f, this is del square f, curl of f, this is this will become gradient of, if you want to write in words, this will become gradient of divergence of f minus del square f. Okay, so these four formula you need to remember. Now this was the last topic from differential vector calculus. Next we will talk about integral vector calculus.